Hey guys, welcome to chapter 4 review. We're on page 240. You're going to follow up with me on each one of them. 4.1 dealt with matrix operations: addition, subtraction, multiplying by a scalar, solving for an unknown. Main thing you want to remember from 4.1 is you cannot add or subtract matrices unless they have the same amount of rows and columns. They have to be the same measurements in order to work. A 2 by 3, you can only add or subtract another 2 by 3. So we have 4 different problems here. We're going to go one by one. This is an addition. We have 2 matrices. First, this is a 2 by 2. This is a 2 by 2. I can go ahead and add it. And addition of matrices is so simple. You go one by one. This is 14. This is -1. This is -4. And this is 10. Right? We just go. Each term with its corresponding term, you add them. You would do the exact same way to subtract, right? You would go 5 minus 4, -2 minus 1, 0 minus 4, 6 minus 4, and so forth. So this is just a very easy solution of 14, -1, -4, and 10. Moving to number 2, first thing we want to do, this is a 2 by 2. This is a 2 by 3, which means we can't do it. We cannot do the subtraction because they have to have the same measurements in order for them to work. Problem 3 deals with a scalar, and we said this is very easy. You literally distribute this -3 everywhere. I'm not going to rewrite it 3 times. That's all we do. So I know how my matrix is going to look. -3 times -12 gives me a +36. This becomes a +18, a -9, a -3, a -6, and a -24. The only way to get this wrong is if you forget this is a negative and you mess up your signs. But that 3 gets distributed to each one of them accordingly. The last type of problem that we did here is solving for x and y. And we talked this in chapter 1. For 2 matrices to be equal, that means their corresponding terms have to be equal. You see how this 2 is equal to this 2? Makes sense? -1, -1. Well, that means that x plus 2 needs to equal -6, which means x equals -8, right? I moved the 2 on the other side. Also, it means that this 3y needs to equal that 9, which means my y is 3. I'm looking at this and going, 3 times what gives me 9? 3. What plus 2 gives me -6? -8. That's how we solve this type of problems. I'm going to let you pause the video now, and we're on 240. I'm going to let you work all the way 1 through 10. Some of them are not possible, and then restart the video and see the answers. Okay, guys, here's your answers. I'm going to step out of the way. You look and check and make sure you have the right answers on all of them. 2 and 4 were not possible to do because their measurements were not equal to each other, right? The rest of them, look at them. That's a 0. I know there's a little bit of a, I don't know how to do this, but that's a -1 and 0. Those are your answers. On 8, 9, and 10, you first had to do the subtraction. So really on 10, you would have had 7y minus 1 equals 6. 7y equals minus 1 equals 6, 7y equals 7, y equals 1. And then on the bottom would have been 5 minus x equals -2, right? And that would make your x. I'm trying to look. No. -3 minus x equals -2. X equals x equals 1 when you divide by that -1. And so forth. You would have to first do the addition, then equal the terms. I'm going to erase this and we're going to move on to multiplying matrices. And we have done this using a calculator. We're going to do one example by hand. And then I'm going to do one of them by calculator. Okay. The example by hand is 6 -1, 5 -2. It's in the book. And I really would always encourage you, if it's just a 2 by 2 times another 2 by 2, I would say always, always, always do it by hand. It's going to be a lot faster. 6301. Okay, and I need to times them, and I need to know what I get. Remember, the first thing you want to remember is this. The way, in order for you to be able to multiply 2 matrices, the number of columns of your first matrix should equal the number of columns of the second matrix. Rows, sorry. Number of columns on this, 2 columns, needs to equal the number of rows on this, 2 rows. If they don't, you can't multiply them. So you go, I have 2 columns. Do I have 2 rows here? Then I'm good to go. this would be the case. How do a multiplier go? 6 times 6, 36, plus negative 1 times 0, 0. This becomes a 36. 6 times 3, 18, plus a negative 1, 17. 5 times 6, 30, plus 0, 30. 5 times 3, 15, plus negative 2, 13. And that is your answer, right? Now, we're going to do another example, and we're going to do this by calculator just because I want to make sure that you also remember how to do it in the calculator. Because if you do get confused, it is okay to use a calculator, okay? Even for a simple matrix like this. Let's pick one up and try to do it. Here it is. We're going to do a, I'm trying to find one. Here it is. Well, do I really want to do this one? Yes, 6, negative 1, 2, 4. No, this is negative 2. This is 1 and 4, 0, 5. Times, and this becomes negative 4, negative 2, 5. And then 4, negative 6, negative 1. First things first, I want to make sure I can times this. This is a 3 by 2. This is a 2 by 3, correct? I know this for a fact. Does this one equal this one? Yes, it does. We can multiply them. How do we do this? We go to our calculator. We turn it on. We clear everything out. We go second matrix. Over to edit. We're going to make this matrix A. We're going to name this matrix B. For A, this is a 3 by 2. 3, enter, 2, enter. And now I'm going to put it by rows. 6, enter, negative 2, enter, 1, enter, 4, enter, 0, enter, 5, enter. I'm going to go second, quit. I now need to introduce matrix B. Second matrix, go over to edit, go down 1 to select your B. We hit enter. This is a 2 by 3, 2 times 3. And now we're going to do it by rows again. Negative 4, enter, negative 2, enter, 5, enter, 4, enter, negative 6, enter, negative 1, enter. Second, quit. I now want to multiply them. We go second matrix, and we select, yes, I want to multiply A times, just your regular times. Second matrix, go one down, and I say I'm going to multiply A times B. I'm going to hit enter, and believe it or not, I'm going to get a 3 by 3. Remember in class we said the new dimensions are going to be given by the number of rows of your first matrix, the number of rows on your second matrix. If you did this with me, you get negative 32, 0, 32, 12, 26, negative 26, 1, 20, negative 30, negative 5. So that's how we do it by calculator, okay? I'm going to let you go ahead and pause the video. I'm going to let you do 11, 12, and 13. I'll have answers on the board for you, but I'm not going to do the whole calculator all over again. Pause and do 11 to 13. Okay, guys, here's your answers for 11, negative 20, negative 84, 40, and 28. For 12, 5, 24, 25, negative 36. 13, you got a 2 by 3, 17, negative 29, 64, 18, negative 36, 72. If you need to pause and make sure that something didn't work right, go ahead. If not, we're going to move on to 4.3. We just dealt with determinants, and we said we have two easy ways to find a determinant. We can have the determinant of a 2 by 2, which we can do by hand, or you can do the determinant of a 3 by 3, which we're going to do by the calculator. Let's do the determinant of negative 2, negative 6, 1, and 4. I believe that's correct. When we do determinants, we said we're going to make your first diagonal, negative 2 times 4, minus negative 6 times 1. This diagonal minus this diagonal. This becomes negative 8 plus 6, which is negative 2. That's why I said this is a lot easier to do by hand. It's easy math. You basically cross multiply and you minus them. That's it. Now when we have 3 by 3, it's a completely different story. 2, 1, 5, negative 1, 6, 3, 2, negative 4, and 2. I'm hoping I wrote this down. This one we're going to let the calculator do it for us. We're going to clear it. We're going to go to second matrix. All over to edit. We're going to edit matrix A. We know this is a 3 by 3 because we cannot find determinants unless it's a square matrix, which means it has as many rows as columns. So this is a 3 by 3. I'm going to do this by rows 2, 1, 5, negative 1, 6, 3, 2, negative 4, 2. If you need to pause to do, because I do it too fast, pause it. But now that we have the matrix in, we're going to go second quit. Second matrix, go over to math. Your first option is your determinant. We just hit enter, and it's going to say determinant of what? Well, we're going to go to second matrix, and we say we want the determinant of A. Hit enter. The determinant is 16. If you look into your book, it's there, right? Now, we also learned this about finding the area of a triangle, and we said the formula for that would have been area equals plus or minus 1 over 2 times. And the way you set this matrix is going to be your last column is just 1, 1, 1. Your first columns are all of your x's, and your second columns are all of your y's. Make sure they correspond. So don't put the x from the first point and the y of your second point ever, okay? Once you get this, you find the determinant using your calculator. You times it by 1/2, and if your determinant is negative, you times it by negative 1/2, because you can't have a negative area. You need a positive area, okay? And you also did the Kramer rule, which we never, ever, ever used. We did 3x minus 4y equals 12, x plus 2y equals 14. If we would be to solve this, we said we always are going to make this into a matrix. I'm going to put a 1 in front of x because I don't have that there. 3, negative 4, 12, 1, 2, 14. And now this is going to tell us what our x and y is. How do we do that? Second matrix. We're going to move over to edit. This is a 2 by 3. So we go now 2 by 3. How do we know this? 2 rows, 1 row, 2 rows, 1, 2, 3 columns. And I'm going to go 3, negative 4, 12, 1, 2, 14. Second quit. I'm going back to my clear screen. Second matrix over to math. And in order to find the solutions for anything, we're going to go all the way down to option B, which is RREF. We're going to hit enter, and it's going to ask us, well, the solution of what? Well, second matrix, we want to use matrix A. We're going to hit enter. X is 8, Y is 3. If you look in the book, that's exactly what they got. We didn't do it by Kramer's rule because I felt that's going to be information you're never going to use. So I'm going to let you pause the video. You're on page 241. Go ahead and do 14 through 21. Please remember, 19, 20, and 21. Don't do Kramer rule. You're just going to put them in, get your solutions out, okay? 14 through 21, then restart the video. Okay, guys, here's your solutions for your determinants. 14 is 21. For 15, you got 12. 16, negative 5. 17, 4. Here's your problem 18. I actually solved it for you so you can see how it works. Your matrix should look like your first point was 0, 1. Your second one is 2, 4. Your third one is 1, 8. My column is 1, 1, 1. So these are all of my x's. This is all my y's. Now I times it by positive or negative 1/2. When I did the determinant, I got a determinant 11. So I keep the positive 1/2. The area is going to be positive. It's 11 over 2 or 5.5. I don't care how you wrote it down. For 19, your x is negative 1, your y is negative 1. 20, x is 3, y is negative 8. And for 21, x is 6, y 0, and z is negative 3. I hope all of this worked great for you. If not, pause the video, see what didn't work, and figure out what you need to repair. We're going to move on 4.4, which dealt with inverses and identity matrices. Please remember your identity matrices. I'm going to write them right here, very small. 1, 0, 0, 1 for a square, a 2 by 2, and then 1, 0, 0, 0, 1, 0, 0, 0, 1 for a 3 by 3. I'm just going to keep it there to have it, okay? In order to find the inverse of a matrix, we use a calculator. We're not going to bother to find anything of that by hand. If my matrix is 7, 3, 5, and 2, and I want to find the a to the negative 1, I use my calculator. I go second matrix, move over to edit. This is a 2 by 2, 2 by 2, 7, 3, 5, 2, second quit. And then all I have to do is go to second matrix and say I want to work with matrix A, and I need it to the negative 1, remember? And then I hit enter. There is my inverse matrix. It's in the book. You can see it's correct. Negative 2, 3, 5, and negative 7. This is the inverse matrix. If you remember, negative 2, 3, 5, and negative 7, right? Now, the problem that we had, and we're going to do one more now just to make sure you get them right, is whenever we do an equation of matrices. So if I have something like this, 1, 3, 2, 7 is a matrix, and I times it by a big X, which is another matrix, it needs to equal this other matrix. It's going to tell us it equals 3, 0, 5, 2. And we said in order for us to solve this, if we find the inverse of this one and times it with it, then we get the identity matrix and we can get rid of it. We get that, which means it just doesn't change the value. So I'm going to go second matrix, move over to edit. It's a 2 by 2 already. We left it there. 1, 3, 2, 7. Second quit. Back to second matrix. I want matrix A to the negative 1. I hit enter, and this is where I went wrong the last time. I'm going to times this by 7, negative 3, negative 2, and 1. But because I timed it in the front of it, I'm going to do the same thing here. 7, negative 3, negative 2, and 1. In the previous video when I did just the 4.4 for you, I forgot and I moved it in the back. Don't ever put it in the back. If you times it in the front here, you're going to times it in the front here. You want to keep the inequality the same. The equality the same. This cancel each other out. We're done. This is just a simple multiplication. Should you feel unsure, go ahead and put this as matrix A. Go ahead and edit and put this as matrix B. Times it by the calculator. But this is pretty fast, right? 21 plus negative 15 gives me a 6. 0 plus a negative 6 gives me a negative 6. Negative 6 plus a 5 gives me a negative 1. 0 plus a 2 gives me a 2. And that is the matrix I was looking for is 6, negative 1, and 2. If I would put it in times it, we get that matrix right back out, right? Those are the steps for you to solve. I'm going to let you pause the video now. We're on page 242. I'm going to go ahead and let you work 22 through 27 and come back and check your result. Okay, guys, here's your answers from 22 to 27. 22, 11, negative 3, negative 7, 2. 23, if you have decimals, it's fine. Remember, you can always do this by going math fraction and get the things. But if you get 0.75, negative 0.5, negative 25, 0.25, and 0.5, that's fine. 24 had no inverse. You should have gotten an error, and on top it says singular matrix or matrix singular. That means it doesn't have an inverse. We ran into this before. So as long as the error says singular matrix, that means you just don't have an inverse to that one. For 25, 1, 1, 5, 6. For 26, the matrix you're looking for is 3, 6, negative 5, negative 7. 27, this is your answer. Negative 3, negative 2, 4, and 7. I have a feeling some of you struggled with this. So my plan right now for this video is to work 27 together with you to see how we get to that answer. I'm going to write it over here. Negative 3, negative 2. I should have not erased it. 4 and 3. This is where we need to get to, okay? Well, you can't solve it the way it is. So the first thing I want to do is move my matrix that's 8, negative 2, 6, and 1 on the other side by minusing it, right? And I can minus those two matrices. So here's what I have. I have negative 7, negative 5, 4, 3, x equals. My matrix is 9, negative 3, 6, 2. And now I'm going to minus that matrix that it's added on the other side. Minus 8, negative 2, 6, and 1. So we treat this like any other equation. We just need the matrix without an x to move on the other side by minusing it. We know how to do this. They have the same number of columns and rows, so I can do negative 7, 4, negative 5, 3, x equals 9 minus 1. 9 minus 8, 1, negative 3 minus 2, negative 3 plus 2, negative 1, 6 minus 6, 0, 2 minus 1, 1. Okay, this is the matrix that I'm left with in here. And now I need to find the inverse of this one, right? We said we plug this in. You know the steps. I'm not going to go through the steps again. The inverse of this matrix, once you put it in and you go to the negative 1, becomes negative 3, negative 5, 4, and 7. This is the inverse of this matrix. And remember, I almost messed up again. Let me rewrite this in here. 1, negative 1, 0, 1. I have to times it in the front just like I did here. Negative 3, negative 5, 4, and 7. They go away. It's a matrix times its inverse gives me the identity matrix does not exist. Let's see if I get the right answers. Negative 3 plus 0, negative 3. Positive 3 plus negative 5, negative 2. 4 plus 0, 4. Negative 4 plus 7, 3. It's the exact same answer. So this is how this problem would have been worked. Okay? I wanted to work this just to make sure that you know how this works. And we are done, and we're moving to 4.5, which really is not a new lesson. And I'm just going to work one example for you. I'm just going to do 2 variables. It works the same with the 3. We did it many, many times. I'm not worried about you at all. X plus 3y equals 10. 2x plus 5y equals negative 2. This x does not have a coefficient. I'm going to put a 1 in. This becomes the matrix 1, 2, 3, 5, 10, negative 2. From here on, I'm going to get my x and my y. I'm actually even going to throw a bone your way, and I'm going to rewrite number 31 in order to pull out the matrix and remind you how it's done. I'm not going to solve 31, but I'm going to write in the book. X minus y minus 4z equals 3. Negative x plus 3y minus z equals negative 1. And then I have x minus y plus 5z equals 3. I'm going to rewrite as a matrix, only with coefficients. Everywhere I'm missing a coefficient, I'm going to go ahead and put it in, because I want to make sure I don't forget numbers. Here's what I get. 1, negative 4, 3. If you look at this, these are your numbers that I'm going to use, right? Then negative 1, 3, negative 1, negative 1, 1, negative 1, 5, 3. From here on, I have a feeling you can take this. We're going to solve this one together. This one follows the exact same steps, except that this is a 2 by 3 matrix. This is a 3 by 4, so you want to make sure you put the dimensions right. Let's solve that first one together. Second matrix, I go over to edit. I'm going to edit matrix A. I always play with that one. It's a 2 by 3, 2 by 3. I'm going to introduce them by rows. 1, 3, 10, 2, 5, negative 2. It's all in there. I'm done. Second, quit. I'm going to go back to second matrix, over to math, all the way down to B. We want to solve this equation. It's going to ask us, okay, we're going to solve for what? We're going to go second matrix and say off matrix A. I hit enter. My x is negative 56 and my y is 22. These are not crazy numbers, but if you look in the book, that is the correct answer. Okay, I'm going to let you solve this one on your own. The answer will be on the board. Go ahead and pause the video. We're going to finish this chapter, 28 to 33, and then come back for the answers. Okay, guys, here's all of your answers. For 28, x is 2, y is negative 3. 29, x is 5 over 2, y is 3 over 2. I would like for you to use fractions, and you know how to do that. If you do a matrix like that, just go math, fraction, enter. And it will do it for you in the fraction mode. For 30, 3 over 2 and 3 over 2, or 1.5, 1.5. 31, x is 4, y is 1, z is 0. That's the one that I set up the matrix for you. 32, x is 19, y is negative 9, z is negative 11. 33, x is negative 3, y is 2, z is 4. The only way these answers get messed up is if your coefficients are off. For example, on 32, you need to make sure that that negative z has a negative 1 there, so you can put a negative 1. On 33, you have a negative y, you should have a negative 1y, right? And also make sure you carry coefficients with signs. So if you have a negative 3y, you write down negative 3, not just 3. And this is it. I'm not really nervous about you solving this test at all. I think you can get this done. Take your time, follow the rules. There's a cheat sheet that I told you can use. I'm okay with that. Instructions for using your calculator, that's your cheat sheet. Go at it, use it as much as you want. I think the most that I'm very interested in is for you to tell me the decoding of problem 32, because I want to know what you get. Okay? Happy testing, and I'll see you in class.